Okay, I wanted to do just a quick little recap before you jump into your homework today. So, as we look at these first types of problems, it's similar to what you did in the last assignment where you're distributing. So let's think about distributing that x in and see what we get. We get 10 times 1 is just 10, but x times x is x squared. Negative 3 times x is negative 3x. Here you want to make sure to distribute the negative 7 to both. So negative 7 times 10 is a negative 70. We still have the x with it, but negative 7 times a negative 3 is plus 21. Here you can combine these middle terms because they're like terms, so we end up with 10x squared. Negative 3 minus 70 is negative 73x plus 21. Okay. Next, as we look at some of these other ones, remember these are similar to what we've seen in the past, right, where you're kind of identifying the pattern, etc. Let's just see what's going on here. So you may look at the multiple choice and be like, okay, what's going on? Are we multiplying here? 4 times 4 is 16, but 16 times 4 is not 36. So maybe I'm adding 12 to get to 16, but when I add 12 here, you get 28. So it's got to be something else. So this one then has to be that quadratic pattern. And you can use it here. Sometimes I find it helpful just to look at it vertically, like, hey, this is x, this is y. I'm going to leave a space for 0 for a second, but this is 1, 2, 3, 4, 5, right? Let's go ahead and see what's going on here. Let's look at the first difference, and let's look at the second difference. Okay. These are what's giving you 4, 16, 36, 64, 100. Okay, I do think drawing out this chart is super helpful because you have to be really particular in the sense when we're saying to get from 4 to 16, I'm adding 12 here. To get from 16 to 36, I'm adding 20 here. To get from 36 to 64, I'm adding 28. And if you ever get stuck, do 64 minus 36, and then I'm adding 36. So notice here, it's not the first difference that's consistent, but when I look at these differences, each time I'm adding 8. So it says the rate at which the f is not constant. The first differences are linear. The second differences are constant. That's exactly what we have, right? The other ones are not true. They're not constant, and it's not a multiple, right? This would make it exponential. This would make it linear. Okay, so we know that it's in a quadratic function. These are the ones that I think are a little tricky. So let's write the explicit equation. So it says f of x equals a is the second difference, which is 8 divided by 2. So 8 divided by 2 for a gives me 4x squared. I'm going to leave the b for blank for a second, and I'm going to go back. We have to kind of keep filling in some of these boxes over here. Like we know the second difference is always 8, but if I go back 8, we're adding 4 here. Here, if you go back 8, you're adding negative 4. So think about this. You're basically saying like 4 plus what is 4? Well, that would be, 0. 0 plus 4 is 4 to get there. So then that means that the c term is 0. So the only question is there a b term? So remember, if you do like y equals 4x squared plus bx plus c, which is our c is 0, so we don't even need to write that. Let's choose another point. So maybe we plug in 4, 1. So we have 4 times 1 squared plus b times 1. So notice here you get 4 equals 4 plus b. So once again, b is 0. So you don't actually even need either of these parts. b is 0, c is also 0. So it's just f of x equals 4x squared. It's actually a pretty easy pattern there. Here it tells you the first term is 4, but I need to write that second part, f of x equals f of x minus 1. But then we're doing that plus mx plus b. So m is your second difference, which is 8, x, and then you need the 0 term of the first difference. So the 0 term of the first difference, when you go back there, it's negative 4. I assume at this point you should be able to, like, if I asked you to graph it, you should be able to kind of plot those x and y values. Okay, let's do one more. When a ball is dropped from a height of 80 feet, the height of the ball in feet h and t is seconds is given by the following function. I want to remind you, especially if you don't have a graphing calculator, I would start using what they call, it's called Desmos.com, but this can be a great graphing calculator for you and just a general calculator if you ever need it. So to kind of understand what's going on in this graph, I'm going to go ahead and let's graph it for a minute. So there's a couple nuances when you're using Desmos. Mine's being a little slow to load here. If you start doing like negative 16 and you type exactly how you see it, like t squared plus 80, it doesn't actually graph for you, but you can have two solutions to that. If you type in h and then with your parentheses, you do like the t, oh, sorry, I didn't want to add the slider, t, and then close your parentheses and do equals. Oh, let's just take off that parenthesis at the end. Then it will graph the function for you, or your other option, if you type it in with x, kind of recognize that x and t are the same, that's another way you can do it. Okay, so now that we have those, we're just looking at this graph. So let's take a look. You can kind of zoom in and out, but notice how the maximum height is at 80, and that's where you're starting. So like, hey, if we look at this graph, let's kind of just draw it for a second. It looks like this. So as we think about x is the same as t here, which is time, and y is the same as like height. So when we're looking at this, that's what your x and y represents. It says describe the function of h of t and how the rate of the height changes as the ball increases until it hits the ground. So the rate of the height is decreasing until it hits the ground, right? It's getting faster, like at a faster rate. It's falling faster and faster. If we wanted to find out when it hits the ground, it's going to hit the ground at that x-intercept. So the thing I love about Desmos is when you kind of zoom in or out, and then you look at this point, it hits it at 2.236. So we know it's at that many seconds that occurs. And then we saw that the maximum height was up here at 80. So it reached at 80 feet at what time? You could say when t equals 0 or 0 seconds. All right, good luck with